Good day, everyone. My name is Kumar Analaki Murali. My metric number is CF210258. First of all, I want to thank Dr. Hartini to give a wonderful opportunity to perform a task regarding hydrology subject. Okay. Um, Myself and you are Malaysian. Okay, so we are born at the Malaysian, and Malaysia is a country located at the equator line of Khatulistiwa, where the climate is categorized as the equatorial. The temperature in Malaysia throughout the year will be hot and humid. Malaysia will face two monsoon wind season, which is northeast monsoon season and southeast monsoon season. Northeast monsoon season will take place on November to February, whereas southeast monsoon season will take place from late May or June to August. Department of Meteorology Malaysia assumed that in January 2023, most of the state in Peninsular Malaysia will be receive a distribution of rain in average of 15 mm to 400 mm. Whereas in Sarawak, most of the parts are expected to receive an average rainfall between 215 mm to 800 mm. In Sabah and the Federal Territory of Labuan, most of the part are expected to receive an average rainfall between 100 mm to 300 mm. Rainfall is known as a precipitation, like snow, hail, drizzle, rain, sleet. So rainfall is an event initially caused by the vegetation, evaporation, and infiltration in soil. When the capacity of the infiltration is less than the intensity of the rainfall, it will cause outflow. Water that flow overland reach a nearby stream or river is known as a surface runoff. Next, I will talk about flooding. So, flooding in Malaysia. Every year, Malaysia will be hit by the flood disaster, and affected area is mostly on the east coast and southern region of Peninsular Malaysia. Most of the part are expected. Most of the state like Kelantan, Terengganu, Johor, and sometimes in Pahang. So flooding is a predominant link to two types of precipitation, which are high intensity and moderate intensity. Now, I will talk about the problem statement of our project. In the recent years, we have seen there is an increase of flood disaster. The major cause of the flooding is higher runoff rate brought on by the industrialization and the loss of flood storage. The daily rainfall measurement from three rainfall gauging stations located in Muar District, Johor. So, namely Liang Batu, Kampung Olah Sepam, and Pancho. This research aimed to determine the annual mean precipitation of the study area, the peak flow, and the discharge of the river at the maximum water level, and the unit hydrograph using rainfall and water level data. The aim of this research is contradictory to Sustainable Development Goal 2022 from United Nations. The goal we focus on this project are related to climate changes, life, land, and below water, and sustainable cities with communities. So the objective of this project is to determine the mean aerial precipitation of the study area, to analyze the peak flow of the proposed catchment location and discharge at the maximum water level, and thirdly is to determine and plot the unit hydrograph for the study area. The research mainly focused on rainfall and water level in the location that we choose in Muar district. The three rainfall stations are Liang Batu, Kampung Olah Sepam, and Pancho. The water level station is Pancho. Rainfall and water level data was obtained from the website of Department of Irrigation and Drainage. Public Info Banjir is one of the website page from the department, and it was very helpful in order to obtain data of rainfall and water level. There is another software that very helpful to study and collect the geographic data named Google Earth Pro. Google Earth Pro is a geographic information system software. The calculation of precipitation is calculated using mean arithmetic method, Bayesian polygon method, and isolated method. I will pass to my friend Muhammad Koyum to talk more about the data analysis.
Hello, hi, Assalamualaikum. My name is Muhammad Koyum bin Razman. My ID matrix is CF210125. Okay, I will continue for the mean area rainfall. They have three methods. Firstly, mean arithmetic method. Secondly, Tyson polygon method. And thirdly, isohedral method. Okay, for the first method, which is mean arithmetic method, the definition is the technique calculates area precipitation using the arithmetic mean of all the points from the data that given. The data that we record from the website Info Public Banjir, we record for the 7 days, and the formula for the mean arithmetic method is total for the 7 days of the two station divided by number of station. So we get the 46 millimeter. Okay, for the second method is Tyson polygon method. The definition is used to determine the average rainfall on the catchment area. And the second now each rain gauge represent the rainfall of the polygon area which enclose that rain gauge. For the formula for the Tyson polygon method is total polygon area for each station times by precipitation and divide by total polygon area. So we get the answer for the Tyson polygon method is 41.24 millimeter. Okay, for the third method is isohedral method. The definition is used to estimate the mean precipitation across an area by drawing lines of the equal precipitation. From the data of 7 days, we get the highest of the data, which is 74 millimeter. So from the answer from the 74, we divide by 5 area to get the average precipitation. So the formula is total area times by average precipitation divide by total area. So the answer we get is 41.18 millimeter.
Assalamualaikum. My name is Nur Kamali Masrura bin Muhammad Zulkifli. My metric number is CF210042. In this I will show the calculation of hydrograph. To find the value of Q, we use the main equation where Q equal to 1 over N multiplied by A multiplied by R power of 2 over 3 and multiplied by S power of 1 over 2. Before that, we need to find the value of A, R, P, and S. In this slide, I already include the formula and how to solve the Q. And we assume that Y is the depth of water level per day. After that, we sum all the Q, and our Q for cross section is 93,460.23 meter cube per second. Next, we do plotting the graph by day versus flow rate. In this part, we use intersection method to get the base flow by solving them in Excel. We made 4 graphs to separate them by week. To get the value of base flow, the point that have been chosen must touch the intersection line. Next, we can find the direct flow by using the formula total flow minus base flow. From the picture, as you can see, the data has been completely calculated and the total of base flow is 27460.31 meter cube per second. After that, we need to find the value of unit hydrograph. Before that, we need to do some calculation. The calculation is direct runoff where we need to convert in a meter cube, and after convert we get 9.89 multiplied by 10 power of 6. Next, we do calculation of equivalent runoff depth where the total direct runoff divided by catchment area, and we get 6.03 centimeter. After that, after get the value of equivalent, the unit hydrograph can be found by the direct flow wave divided by equivalent of runoff.
My name is Rafika Natasha Jasmine CF21029. In this video, I'm going to explain about the peak flow. To find a peak flow, we assume that area of catchment is 1.64 kilometer square, and we convert to 164 hectare. And to find the peak flow, we have two methods, which is a rational method and cross section of the river method. Okay, rational method is one of the methods that's suitable to find the peak flow of discharge. However, it is not suitable for our case because of the area of catchment is bigger than 80 hectare. Next, to find the peak flow or using rational method, we have to use the equation that from Math, a second edition, and we have to find the average rainfall intensity using empirical IDF curve based on the Math second edition too, and we have to find the average recurrence interval, storm duration, and fitting constant depending on the rain gauge location. To find the fitting constant, we have to see the table that has been given in MASMA second edition, and we have to find our station name, and there have value for our constant. But however, there's no our station in the table, so we choose the nearest station that close to our station, which is Seto JPS Batu Pahat. We managed to find the intensity. We have to find the runoff coefficient, which is we choose from the table that has been given in MASMA 2. We choose residential and link and terrace house because the characteristic of this place is more to link and terrace house residential. And after we find our coefficient, we then calculate our peak flow, and we managed to get 58.31 meter cube per square as our peak flow using the rational method. The second method to find the peak flow is we use the cross-section profile of the river at the maximum water level. To find the discharge, we use the Manning formula, and we have to find the area with the perimeter, hydraulic radius, width of channel, slope, and Manning coefficient to solve the discharge using the Manning formula. And our river have a half triangular shape, and our width is 93.8 meter, and slope we calculate is 0.11, and we choose the Manning coefficient as a 0.035 because the characteristic is suitable for the river. And then we managed to get the discharge, which is 5091.56 meter cube per square. For the comparison, there was a lot different between the value of the rational method and the cross-section profile of the river at the maximum water level method, and to get the peak flow. The cross-section profile river at the maximum water level method is more accurate than the rational method because the rational method is not suitable for us, and because our area is bigger than 80 hectare.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Aiman bin Ramal Arifin. My matrix number CF210044. Today I want to present discussion and conclusion about our team project. Discussion. The arithmetic mean method, the Thiessen polygon method, and the isohedral method are all used to calculate the mean area precipitation. The average of precipitation using arithmetic, Thiessen polygon method, and isohedral method are 46 mm, 41.24 mm, and 41.18 mm. The peak flow was calculated using the rational method and the river cross-section method. The respective discharge rates are 58.31 meter cube per second and 5091.6 meter cube per second. The hydrograph is a graphical representation of runoff rate versus time. It depicts the temporal distribution of runoff at the point of measurement or calculation, using a single curve to express the watershed's complicated properties. Conclusion. By completing this project, we learn how to recognize and manage the precipitation runoff relationship. We can confirm that as precipitation increases, so does runoff until the peak of release. Common stream waste shape are the critical components that influence runoff preparation.